Programming with Python, on Binder. The main objectives of this tutorial are to introduce the Programming with Python lesson created by the software Carpentry, explain how to complete this lesson using Jupyter Notebooks on Binder, demonstrate the first part of this lesson, and recover from inactivity using browser storage. Software Carpentry. Since 1998, Software Carpentry has been teaching researchers the computing skills they need to get more done in less time and with less pain. This predominantly volunteer organization creates and maintains freely reusable curricula on topics such as Unix, Git, Python, and R. In this tutorial, we will focus on the introductory Python lesson named Programming with Python. Note that in addition to finding at the main Software Carpentry website the aforementioned lessons on Unix, Git, and R, you can also find the source code, instructor notes, and even translations into Spanish. The main web page for each lesson describes the goal, in this case learning how to program in the context of data analysis. Specifically, this lesson teaches you how to analyze a dataset studying how a new treatment affects daily inflammation amongst arthritis patients. Shown here is an example of the data, where each row represents the number of inflammation bouts a particular patient experienced on a given day. You will learn how to calculate the average inflammation per day across all patients and plot the result to discuss and share with colleagues. At the bottom of this page is a schedule showing the 12 parts that make up this lesson. Note that the left-hand column estimates that this lesson may take up to 8 hours to complete. You will spend the first part of this lesson getting a high-level overview of the dataset by loading and visualizing the dataset using the Python packages NumPy and Matplotlib. These exercises will provide familiarity with basic Python and the Jupyter Notebooks environment, which we will cover next. The rest of this lesson will be spent practicing core concepts like loops, lists, conditional statements, and most importantly, deciphering and fixing error messages. Each part of a lesson starts with an overview including estimated time, motivating questions, and learning objectives. The core content is then presented as a continual series of narrative, input, and output. This interwoven style is an example of literate programming where computer code and output is explained and motivated using human prose. To clearly identify computer code from human prose, the Python commands and output are typeset inside boxes using a fixed-width font. Finally, EACH part of a lesson ends with practice exercises and a summary of key points. Jupyter Notebooks on Binder. The Software Carpentry curriculum only provides a lesson to teach and learn Python. To actually work through and run the examples and exercises, we will need a computing environment that provides Python. Here we will describe how to complete this lesson using Jupyter Notebooks hosted on Binder. Jupyter Notebook is an open-source framework that allows you to create and share documents that interweave code, output, and narrative text. While this computing style is not suitable for every problem, it presents an approachable environment from which to introduce people to programming. At the core of the Jupyter Notebook user interface is the code cell. This is the place where users enter commands that will be evaluated by the selected programming language. Note that while this is labeled as a code cell, it is also the place where one inputs narrative text. Importantly, Jupyter Notebooks is a modal editor. Specifically, a code cell can be in either edit mode or command mode. The color of the cell provides a visual clue as to the mode, with green indicating edit mode and blue indicating command mode. In edit mode, you can freely change the code inside a cell, while in command mode, you can run or cancel the command. Here is an example of an actual Jupyter Notebook. Note that he currently selected code cell as the first code cell and that it only contains narrative text, a great way to provide an overview. Furthermore, this cell is colored blue indicating that it is in command mode. Finally, a table of contents in the left-hand column provides a way to follow your progress. We will work through an actual notebook in the final part of this tutorial. While we have described a computing environment, namely Jupyter Notebooks, we haven't discussed what computer we will use to run these Jupyter Notebooks. Here, we will take advantage of the mybinder.org, a public service for those who'd like to share their interactive repositories publicly. This nonprofit organization funded by the C-MOOR Foundation and Google Cloud provides free access to Jupyter Notebooks to anyone with an internet connection and a modern web browser. Before walking you through Jupyter Notebooks on Binder, there are two very important caveats. First, Binder is designed for publicly available material and does not secure your sessions. Thus, do not input any sensitive information such as passwords. Second, Binder is designed for demonstration purposes and not as a complete compute environment. Thus, expect Binder sessions to disappear upon inactivity and plan for the possibility of restarting from scratch. Those two caveats aside, Binder provides a tremendous free resource to a rich compute environment that we can leverage to complete software carpentries, programming with Python, lesson. Demonstrate Python fundamentals. We will now demonstrate how to start a Jupyter Notebook using Binder as well as explain some basic user actions inside Jupyter Notebook. Note that this is not meant to be comprehensive but rather an overview to guide your learning. First, open the QBB2020 GitHub repository using mybinder.org. This may take anywhere between a few seconds to a few minutes. Click on Show to see the status of the boot up process. Click on the Prep folder to find the preparatory work. Click on a Jupyter Notebook to start that part of the lesson. Shown here is a typical starting point view of a Jupyter Notebook. Click on the first code cell marked in and notice that it turns green to indicate that you have entered edit mode. Run this code by holding down the Shift key and pressing the Enter key. The code is evaluated by Python as 23. Be sure to play around with each code block to make sure you understand what is going on. For example, change the code from multiply by 4 to multiply by 5 and press Shift plus Enter. If you double-click on narrative text, you will see the underlying Markdown code. Markdown is a special way to indicate how each portion of a text should be typeset. To render the Markdown code, run the code by pressing Shift plus Enter. Note that after running a code cell, Jupyter Notebooks automatically advances you to the next code cell. In this manner, you can quickly run each code cell in a notebook. Press Shift plus Enter again to advance to the next code cell. Note that while you ran the Python code, weight_kilogram equals 60, there is no output. This is the case here because you are only storing the value 60 in the variable weight_kilogram. In order to see output, your command must output some value and it must be the last line in the code cell. Both conditions are now satisfied in this example. Here we encounter an error message. Specifically, there is a name error indicating that the variable weight_kilogram_text is not defined. This occurs because we didn't run the preceding code cell above which defines the variable weight_kilogram_text. This underscores an important point about Jupyter Notebooks: execution order and state matter. The numbers inside the square brackets indicate the order in which these commands were run. In this case, the lack of a number indicates that the code cell was never run. Here, the code runs properly after running these 4 cells in order. Here is another example of a code cell with which you can experiment. Note that the conversion factor 2.2 is coded directly in this command. Using what you learned earlier in the lesson, you can define a variable named kilogram_to_pound and refer to it accordingly in the print command. Red text marks special terminology. Hover your mouse pointer over the word to reveal a definition in a pop-up text box. The end of each notebook includes exercises to practice what you just learned. Use code cells to try out different commands to help you solve the problem. If you need additional code cells, you can click on the plus icon. Try an experiment not only with each code cell but with the entire notebook as a whole. Here, we comment out the second command in the code cell by adding a hash symbol at the beginning of the line. Do you understand why running this code cell repeatedly now produces different answers? Save to browser storage. In the final part of this tutorial, we will show one way to recover from a Binder session that has been terminated due to browser inactivity. This is apparent by the shown connection failed message. This is also apparent by a not connected status message in the upper right-hand corner. Fortunately, recent versions of Jupyter Notebook provide a button that saves the current notebook to your browser storage. Click on the cloud icon in the toolbar with a down arrow. This will save your current notebook to your browser storage. Now reconnect to mybinder.org. After opening a fresh copy of the same notebook, click on the cloud icon with an up arrow. You will be prompted to agree to replace your current notebook with the copy stored in your browser storage. Click OK. Voila! You have now recovered from inactivity using browser storage. In this tutorial, we introduced the Programming with Python lesson created by the software Carpentry, explained how to complete this lesson using Jupyter Notebooks on Binder, demonstrated the first part of this lesson, and recovered from inactivity using browser storage. Some possible next steps are to review the primary textbook chapter for Part 1, Python Fundamentals, and complete the Jupyter Notebook for Part 2, Analyzing Patient Data. Thank you to all the people that helped.